Hi everybody. What you need to get through this particular portion of the notes is your guided notes for the numbers unit, and you need to turn to page 2, okay, where it says scientific notation. All right, you should have seen scientific notation before and or learned about that particular method, but we're here to review that briefly so that we can practice in class. So with scientific notation, basically the purpose of that is it's a way for us to express really large or small numbers in a more simple format for writing it. And then as well, it'll also need to be typed into your calculator a specific way in order to perform upcoming calculations. A great example to use is the speed of light. Most of you have taken a physical science course and are familiar with that term, but the speed of light is 3.0 times 10 to the 8 meters per second. So it's a lot easier to write the 3.0 times 10 to the 8 meters per second than it is to write out all of the zeros that are in addition to the number 3. So there are some rules for writing scientific notation correctly, and the first is you're going to simply move the decimal place until there's only a single number in front of the decimal place. Refer back to the example for speed of light. There's only one number in front of the decimal place, and that is a 3. And we call that area, if you look at the very top here where it shows the scientific notation, the M will represent the very first set of numbers that you will write. Then basically what you do is you count the total number of decimal places that you moved your decimal, and that is what is considered to be n, and so that is the power of 10 that you will write. And so for the speed of light, we move the decimal place 1, 2, 3, 4, 5, 6, 7, 8. And so we say 3.0 times 10 to the 8 meters per second. If the number is a small number, you use a negative in front of n. If the number is a large number, then you just use the positive value, and you don't have to write the plus, but we understand that that's a positive value. So I think everybody agrees here that this is a very large number. So therefore, it's just a positive exponent for n to represent that I'm dealing with a number that is large. So here's one to practice here. So we've got 34,000, and we want to turn that into scientific notation. I hope you would agree that we would consider this a large number, so that means that my n value is going to be positive. So I'm going to take my decimal and move it. Now the understood decimal is here at the very end, and I'm going to move that 1, 2, 3, 4. And I'm going to write my answer as 3.4 times 10 to the 4th power to represent the fact that that is 34,000. Let's practice some more together. And these should be right here on your actual worksheet. And I see here on your other example, it shows you another one here that's small. So on your examples under scientific notation, it says 0.0025. And so when we wrote that in scientific notation, we moved the decimal place in between the 2 and the 5, and that was a move of 3 places, so 2.5 times 10 to the negative 3. So our very first number here, which is 4,100,000, we need to place that into scientific notation to better represent it. So we're going to move the decimal place to the left. All right. So that's going to be 1, 2, 3, 4, 5, 6 places. So correctly, that would be written as 4.1 times 10 to the 6th power. Our next number, I think you guys will also agree, is a very large number. So I'm going to go ahead and give you guys a second to work that one out, and then I'll report the answer to you. I've counted a move of 12 spaces. I hope that you agree with that. And your second question might be, well, Miss Scorty, what all numbers do I continue to write? Write all numbers that are non-zero numbers for the moment. We'll talk about significant figures later. But I'm going to write down the 3, the 4, the 5, and the 6. And I'm going to say 3.456 times 10 to the, wait, hold on, 3, 6, 9, yeah, to the 11th power. I'm sorry, I said 12 at first. Please excuse me. To the 11th power. All right, let's look at the next one. Is this number a large or a small number? I hope everybody would agree that this is a number that is less than 1, and so are the next two. So all of these, we should be adding a negative exponent there above the 10. So in this case, for this one, I'm going to take the decimal place and I'm going to move it 1, 2. So it's going to be in between the 4 and the 5. And I'm going to say 4.5 times 10 to the negative 2. I'm going to go ahead and let you guys do the next problem, and then I will follow through with you. All right, so let's look at this one. So here's my decimal place. I'm going to move that to the right in between the 1 and the 2. That's 1, 2, 3, 4, 5, 6, 7. So that's going to be 1.2 times 10 to the negative 7. And our last one, I hope you've had a chance to do that one. We're going to move this to the right as well because this is a number that's less than 1, and we'll also need a negative exponent. So that's 1, 2, 3. So I'm going to say 3.05 times 10 to the negative 3. All right, now we can also take a number out of scientific notation as needed. What we need to do, the best strategy is to decide, is the exponent a positive or negative value? And from there, that would lead me to know which way I need to move my decimal place. So let's look at this first one here. This first one is to the 3rd power. That's a positive, so that means this number must be a big number or a large number, which means I'm going to need to move my decimal place to the right so that it becomes larger whenever it is written in standard form. Right, so here's my decimal place here. I'm going to move that 1, 2, 3, and I fill in any zeros wherever that blank occurs. In this case, it is 1. So that's 4,670 would be the correct way to write that in standard form. All right, guys, our next number is also a large number. So we're going to move the decimal place 5 places to the right. So that's going to be 1, 2, 3, and then 4, 5. So I'm going to add 2 zeros past that 2, and let's see what our value is here. We have 311,200. All right, guys, our third number is a small number. So which way am I going to move that decimal place? I'm going to need to move that to the left because the negative 4 means I have a small number, and so I should move my decimal place to the left to have zeros to represent a number less than 1. So here I'm going to move that 1, 2, 3, 4. So that's going to be 3 zeros I place in front of the 3. Right. And so that's 0 point, and there's the 3 here, and then 3, 1, 1, 2. I'm going to go ahead and let you do the next two, and we'll go over those. Okay, this one's 4 times 10 to the negative 6. And so I'm going to move that decimal place to the left again, and the understood decimal place is right here past the 4. So that means that I'm going to move that 6 places to the left, which means I'm going to end up having 5 zeros in front of the 4 because the 4 represents one move, and that's 5 more zeros in front of that. So that's 0.000004. And our last number is a large number, and so that's a move of 11 places. The understood decimals here right past the 1, so that means I'm going to add 11 zeros past the 1. And we have a lot of money, don't we? All right. See you in class.